All right, we're continuing on in Chapter 5. This is our last lesson we're going to go over this semester. It is solving compound inequalities. So we've talked about solving inequalities using addition and subtraction. We've talked about multiplication and division. And now we're going to put some inequalities together. So a compound inequality is when you have two different inequalities and you're putting them together, solving them together, and graphing them together on the same number line. All right, so here, first thing we're gonna look at is inequalities, compound inequalities with the word and involved. And I'm gonna kind of do it in my own way. I think it's easier this way. All right, so when we have compound inequalities with and involved, you're either gonna see the word and, so it'll be something like this inequality and this inequality. Now these are already solved. These are just the answers, right? There's nothing for us to do. So we're gonna graph the solution. And also you could see it this way, where x is in the middle. Now this isn't solved yet, so I'll show you what it looks like solved, but these are two different ways that you can see an and compound inequality. This is an inequality, this is an inequality, and together, whatever answer solves this is also going to be an answer for this at the same time, right? Same thing down here. This is one inequality, this is one inequality, and whatever answer we get for x, it solves both inequalities at the same time. Okay, so if I was gonna solve this here, in blue, not even red, x is less than 2, okay? And x is greater than or equal to -1. Well, this is a number line, so I'm gonna put the smallest number on the left, -1, 0, 1, 2, 3, 4, 0, 1, 2. Okay, so here's our number line. I'm just writing down the two numbers that are in my answer. All right, if x is less than 2, this is an less than sign. There's no line under it. So above the 2, I'm going to put a circle, and I'm going to leave it open. There's no line here, so I'm leaving my circle open. Okay, and then if x is anything less than 2, I'm going to shade all of this, right? But x also has to be greater than or equal to -1. So I'm going to put a circle over -1. This does have the line underneath it. So I'm going to shade this in. And in this case, I'm going to shade all the numbers bigger than that, right? So the part where these two graphs overlap is this stuff in the middle. So for this compound inequality, x is less than 2, and it also has to be greater than or equal to -1. So all these shaded numbers here fit that description, right? And when we write this, we didn't have to do any math, but I actually lied because we're not completely done simplifying the answer. When I write this, I'm gonna always write, there's some rules here to the side we're gonna go over. I'm always gonna write the smallest number on the left, the biggest number on the right in my answer, and x is gonna go in the middle with a compound inequality, okay, when it's an and compound inequality. Okay, and then I'm not changing it, so here, x and -1, the mouth is open towards the x, so I'm gonna keep it open towards the x with the line under it. And for this one, the mouth is open towards the 2, so I keep the mouth open here. So this makes a little more sense when we're looking at this graph, right? The shaded part is x. So the shaded part is in between -1 and 2. The shaded part is in between -1 and 2. It looks exactly the same, right? If we wrote it down here, -1, x, 2. These line up. X is all the shaded stuff in the middle. And these two dots represent our two inequality signs. This one's shaded in. This one is open. Right? So some of our rules for and inequalities here, just kind of try to summarize them briefly, and rules. We always write in our answer, or should put answers. When we're all done and we want to graph and we write our answer, we always write the smallest number on the left and the biggest number on the right, just like I did here. And this is my answer. This is how I'm writing it. Okay, always put the smallest number on the left, biggest number on the right. Up here, they didn't do that, right? Which is fine. This is still the answer. There's no math to do here, but it's just not finished, right? Well, we're going to write the final answer. We're going to put this -1 over here and this 2 over here because smallest is on the left, biggest is on the right. Second rule when you're writing an answer to an and compound inequality is that the signs open in the same direction, and they open towards the right. So if we look at this right here, this sign is opening this way, and this sign is also opening this way. So all and compound inequalities are going to open the same direction. Okay, and then lastly, x is in the middle. X represents the shaded part, so it's always in the middle for an and compound inequality. So those are my little 3 rules. You can write those down, pause the video, rewind it. Those are always true for and compound inequalities. Let's do one here where we have to solve, and it's very, very simple. So we've actually got 2 inequalities. This is one. This guy, I'll try and put it up at the top so we don't get confused. That's one inequality, and then the other one is this one, right? And we're just putting them together. They're true at the same time. They're one compound inequality. So to get x alone, I need to get rid of this plus 2. So to get rid of it, I'm going to subtract it. Well, I got to do the same thing in this inequality. I got to do the same thing here, right? I got to subtract 2. And in this inequality, I got to do the same thing here. I got to subtract 2, right? So wherever you see a symbol, there's 2 of them now because this is a compound inequality, not just one. Wherever I see a symbol, I got to make sure I'm doing the same thing on every side of those symbols. So I'm subtracting 2 everywhere, okay? These 2's cancel, so I'm left with x. -1 minus 2 is -3. -3 minus 2 is +1. And I bring down my symbol, and I bring down my symbol. So here's my answer, right? So is the smallest number on the left and the biggest number on the right? Yes, it is. Is x in the middle? Yes, it is. Are both sides opening towards the same direction, which is over here to the right? Yes, they are. So I'm done. This is my final answer. So on my number line, I'm going to put a -3 and a +1. You can go to the trouble of saying -2, -1, 0, 1, 2, 3, whatever. You can do that. I don't go to that trouble. As long as I have the numbers in my answer on my number line, that's all that matters. Okay, so my symbol here at -3 does not have a line under it, so I leave this open. Same thing with 1. There's no line underneath, so the circle I put on 1 stays open. And then x is in between those 2 numbers, so I'm going to shade in between these 2 numbers. So this is showing me that all numbers on a number line in between -3 and 1, not including -3 and 1, just in between there, could solve this compound inequality. It would make it true, right? And again, my solution is -3 is less than x, which is less than 1. This is my answer, and it kind of mirrors the picture there. Okay, so once again, 3 rules. Write smallest number on the left, biggest number on the right in your answer. Signs always open in the same direction to the right, and x is always in the middle. You shade in the middle. The shaded part represents what x could be, so it's always in the middle. All right, so let's do a couple examples, and then we'll move on to OR compound inequalities. All right, graph the solution set of each compound inequality. So here they're written out. They're not kind of how we would write our final answer if we were solving, but we can still graph them from here, right? So we always write smallest number on the left, biggest on the right. So I'm gonna write -1 here, 3 here. My variable here is b, so it goes in the middle, right? And my sign's always open in the same direction. So for this inequality, the mouth is open towards b, so I keep it that way. For this inequality, the mouth is open towards the 3, and it has the line under it. So this is what I'm graphing, right? So I put a circle on -1, but I do not shade it in. I put a circle on 3, but I do shade it in because it's got the line under it. And then b is in between, so I shade everything in between. All and compound inequalities, answers with the word and in them, or when they're put together like this, like one big inequality, they're always shaded in the middle. Or compound inequalities are different, ands are always the same. All right, for this one, okay, they wrote this out. This is the answer. There's no math involved, but we got to rewrite it to finalize it, right? So here we want to put the smallest number on the left, the biggest number on the right. My variable is q, so I'm going to put it in the middle. And then here, out of this inequality, the mouth is open towards the 2, and it's got the line under it. Here, in this inequality, the mouth is open towards the q, and it's got the line under it. Okay, so we're going to put a circle above -5, and we're going to shade it in. We're going to put a circle on 2, and we're going to shade it in. And then q is in between, so we're going to shade everything in between that represents q. Good, making sense. Let's see, they're all kind of the same. Let's do one more. This is already finalized. This meets all of our criteria. P is in the middle, smallest number on the left, biggest on the right. Signs open the same direction, so we're done. So I'm gonna put a circle on -2, and this sign has a line under it, so I'm gonna shade it in. I'm gonna put a circle on 4. There is no line under this symbol, so I'm not gonna shade it in. And then P is in between, so I'm gonna shade everything in between. Okay. Awesome. Number 5. We'll do number 5 and then I'll go on to the other ones at the bottom. We got to solve some math. D is greater than -3 and D is less than 2. So basically we're just taking out this, and this is our one big inequality, right? -3 less than D less than 2. That's our answer. So I put a circle on -3, no line under it, so I leave it open. Circle on 2, no line under it, so I leave it open, and I shade everything in between. Once again, because I said this in the last couple videos and I still had students hand in stuff not done this way, do not, I'll do it on this paper. If you have a number line, and let's say your answer is like 2 and 4, and it's like 2 is less than or equal to x is less than 4, and you have to shade it in, do not shade it up above the line like this. This is not correct. Yeah, you did the right stuff. This is correct. You have to do it directly on the line. That's what the line is there for. You will never see in a multiple choice test, you will never see an answer choice that has a number line with the shading above it like that. That is incorrect to do it that way. You have to shade directly on top of the number line. So please remember that for your work. All right, let's do a couple where we're solving and then we'll move on to video 2, which is the OR problems. All right, number 4. Here, all we have to do is subtract 3 to get W by itself. So I gotta subtract 3 here and I gotta subtract 3 here. So I'm gonna have 4 less than W plus 3 less than or equal to 5 minus 3 over here, minus 3 over here. Why am I doing that 3 times? Because remember, these are actually 2 inequalities. So if I cover this one up, I have this inequality, and I have to subtract 3 here, so I do it on this side of my symbol. And I also have this inequality, so I gotta do the same thing on both sides of this symbol, right? So I'm just doing it all together at the same time. So these go away. 4 minus 3 is 1. Bring down my sign. W, bring down my sign, 2. Okay, so here we go. We've got the number 1 with a line over it, and it is not shaded in. 2 with a line over it, and it is shaded with a line under it, so it is shaded in. And then we shade everything between it. Good, makes sense, hopefully. And it's okay if your answer looks tiny like that, that's fine. Let's do, this one's kind of similar. Let's solve this and problem down here. Let's solve it first and then write our answer correctly. All right, so for this first inequality, all I want to do is add 2 to both sides. N minus 2 is greater than -3. I want to add 2. N is greater than -1. And for this one, I want to subtract 4 from both sides. So N plus 4 is less than 6, minus 4, N is less than 2. Okay, so these are my 2 compound inequalities. I want to put the smallest number on the left, the biggest number on the right. So -1, 2, N goes in the middle. And then for this one, the mouth is open towards the N. And for this one, the mouth is open towards the 2. And there's no lines under any of this. So this is my answer that I'm graphing here. Okay, so I put a circle above, I say above, on top of -1. There's no line under it, so I keep it open. A circle on top of 2. There's no line under it, so I keep it open. And N is in the middle, so I shade in the middle. Okay, so even though it has the word and in it, but it's written separate, once you solve it, you get down to one number on each side of the inequality signs, then you can write it out using our rules. Let's do one more over here. Let's do this bottom guy, number 12, because it looks interesting. All right, so we've got this whole big thing here. I'm going to write it out to the side. D minus 3 is less than 6D plus 12 is less than 2D plus 32. All right, so I want to get D in the middle, right? I need to get rid of some D's. Actually, you know what? I'm gonna solve these separate. So first thing I'm gonna do to solve this is just look at this side. I think this will be easier to do it this way. To get D by itself, I need to get rid of the smallest, so minus D. So I'm left with -3 is less than 5D plus 12. Then I subtract 12 from both sides. -15 is less than 5D. Then I divide both sides by 5. When you divide by a positive, your sign does not flip. So this is -3 is less than D. So there's one of my answers, right? The other side of the inequality that I blacked out here, now I'll black this side out. This side was less than, was it 2D plus 32? 2D plus 32. All right, so out of 6D and 2D, my smallest D is 2D. So I subtract 2D from both sides, and I get 4D plus 12 is less than 32. And then I want to get rid of this 12, so I subtract, so I get 4D is less than 20. And then I divide both sides by 4, D is less than 5. Right, and so I'm done. Here's this answer. Okay, so when I want to write the answer all together, smallest number on the left, biggest number on the right, so -3 goes first, 5 goes at the end, D is in the middle. And then my sign here is open towards the D. My sign here is open towards the 5. So this is my answer that I'm graphing. So I put a circle above -3, leave it open, a circle above 5, leave it open, and then shade everything in between. Yeah, so you can do it like that sometimes as well. Sometimes if it gets kind of complicated, like that one involved a lot of variables, I just ignored one of the inequalities, solved one of them first, and then ignored the other inequality and solved the second one first, and then I just put my answer back together.